we rollin'. Some rock, some wind, some rollin'. Some rock, some wind, some rollin'. Some rock, some wind, some rollin'. Some rock, some wind,
Hi, my name is Loris Crow, and we are executing a Showtime. Zig Showtime is the show where members of the Zig community come on stream to share coded ideas with the broader public. Every episode features two speakers who will present and take questions from you, the viewers. Zig Showtime is not just what you're seeing on the live stream, but also the discussions that you can have while watching. And that's why I encourage you to join one of the existing Zig communities that you can find by going to zigland.org. So, welcome back. It's been a while, I know. Just to give you a couple of updates since the last Showtime. Let me bring up some graphics. So, first of all, as you might know, we have the Zig Software Foundation. We are looking for donations. The fundraising is not going bad. We need more, of course. We are not quite at the goal yet, but things are moving forward. And there's also some donations that don't show up on GitHub because come through other means. Not bad. I'm happy with the progress that we're making. Also, in other news, always Zig related, there has been some discussion on Twitter apparently about Zig by some personalities. This is a tweet from Antirez that tried both Zig and Rust and shared his opinion, which I think is interesting. It's a positive opinion about Zig, even though not a definitive endorsement, but not bad. After that, there has been also another discussion where John Carmack also apparently is looking into Zig. John, if you're watching, hi. So that's also nice. And after that, final news. If you're not aware, there is also a Zig Showtime YouTube channel where I usually post the recordings of the live stream, but I'm starting to do content that doesn't come from Twitch, so YouTube-only content. In particular, you might be interested in the community update that I posted, and as I get more used to making videos, I'll try to add more stuff at a better pace, let's say. Okay, so that was it for the introduction. Let's see if there's anything else. Not really, and I think we can move to the first talks. So let me bring up the title. You might be used to a short introduction with a joke from me, but for some reason, for this time, I couldn't find any quick joke to make. So I don't know why I came up with longer stories, more long-winded jokes. But if you know the reference, you might enjoy it anyway. So this is how it goes. Let's say that tomorrow you decide to write your own web browser from scratch. The obvious superior choice is to write it in JavaScript and bundle it in Electron, of course. There's also something poetic in having both the trusted and the untrusted part of the interface be in HTML. I'm sure nothing bad could ever come out of that. Now, you might think that when you load a website inside your web browser, there's two virtual machines involved. One is running the website's JavaScript, and one is running the Electron application. But on Linux, there's another secret virtual machine hidden somewhere. And the truth is that everything runs on virtual machines and on a virtual machine. And if you wonder what that virtual machine is running on, well, the answer is that it's virtual machines all the way down. Maybe I'm exaggerating, but there really is a curious type of bytecode that you can run in the Linux kernel. Matt Knight is a C programmer that works for a Linux security company and is going to tell us more about it. The title is BPF with Zig, and Matt, the stream is yours.
Hey everybody, so yeah, a little bit about me. My name is Matt Knight, and as Larry said, I'm a C dev working at a Linux security company. I do mostly systems programming. If you've got questions after this talk that you want to talk about with me, feel free to contact me at any of these social media platforms. Usually up for a username close to my name, but for Twitter, I settled on Embedded Boy. So yeah, today. So I've been, BPF is something that's been on my queue of things I've been wanting to learn for the last couple of years. And the company I work for released a free product that uses BPF. And so I thought, hey, you know what? Let's jump right in. I'm by no means an expert on this, but I thought it'd be a good time to do a talk because I've been doing a lot of learning. And number one, I've learned that writing BPF in Zig is a lot of fun. And two, there's not a lot of documentation and resources, and I wanted to make it easier for some people to understand some of the lower level aspects of it. So first, I'm going to tell you what the hell BPF is, and then we're going to go over a couple examples of kind of like they both do the exact same thing, but they use slightly different methods on how to load BPF code into the kernel. And then we're going to kind of talk about where I want to see the Zig BPF library go, and some things that are coming down the pipeline for just BPF in general. So BPF is a Linux kernel subsystem. The name stands for Berkeley Packet Filter, but now it's a misnomer because it's been extended way beyond just simple packet capture. And I think the best description of it is that it's a method to run user space code inside the kernel and to do so safely. And it does this by having a VM or a virtual machine in the kernel. And the way it works is that you request the system to run a certain chunk of BPF code when an event fires in the kernel. And in that process or the request, it goes through a static analyzer called the BPF verifier, which is able to determine if the code is safe or not. And we'll get into that a little bit in a couple minutes. So obviously, from the name, the uses for today have to do with packet processing and networking, but a lot of support has been put into tracing the Linux kernel itself. There are other systems it deals with. It's more than just these two things. There's also integration with C groups. I don't know. I still have a lot of learning to do on C groups, but from my knowledge, it's what makes containers possible. And so you can do like tracing and know which container you're tracing and stuff like that. The reason why you'd want to use BPF is one, you want to go fast, and it's also able to give you a level of observability and add a fine-grained detail that you just can't get from user space. I think we're not going to deal with XDP today, but this is a really cool example. XDP is a subsystem as well in Linux, but it uses BPF, and it stands for Express Data Path, and you can do software-defined networking in it. So you can make routers, you can make your own firewalls or proxies, and stuff like that. And it's really cool because some the hooks into the system allow you to intercept packets right as they're coming out of the network card. And so that's like from a firewall perspective, you can drop packets before it goes through the Linux kernel's network stack, and before it even goes through allocation for socket buffers. Another really cool edge case for it too is that if you have a network card that has the drivers support the interface. What you can actually do is you can offload BPF code and data structures to that hardware and execute over there, and just not have to deal with any of it on your own processor. So getting back to some of the safety parts, so the verifier is able to guarantee safety first by putting your code under some pretty restrictive constraints. So the first one being there's maximum 4096 instructions per BPF program, and another noticeable one is that before version 5.3 of the kernel, you couldn't have any loops, which is pretty big. And then now after 5.3, they have bounded loops, which are the compile time known size of the loop or how many iterations you're going to do. And it's with these sort of restrictions that I think Zig is going to be really powerful at, because the code size is small. And then stuff like inline for loops make it really nice to have the high level feeling of loops without actually creating code that does loops. With the size, I know the size is really tiny, but there are ways around it. So there is something called tail calls. And so the idea is that you can have a BPF program call another BPF program through like a reference, which is just a file descriptor. It has to be loaded into this program map, and then you can access other programs based off of an index. And max 32, so there is still a limit. It works really well in applications where, like, let's say you're doing packet filtering and you need to catch or determine, you have different things to do. If it's TCP, UDP, ICMP, well, you can have a single BPF program determine which type, and then depending on the type, call another program that does whatever actions you want. The way this works, though, is that there is no return. Once you make a tail call, it completes the other program, and that's it. Next, you might be wondering, like, okay, we got these programs. How am I gonna deal with it in user space? And so there's kind of like three ways to get information out of a BPF program. The first are BPF maps. They're key value data structures that are managed by the kernel and are read and writable by both the BPF programs and user space. So that's a really flexible mode of communication. The next are perf events. We're not going to talk too much about them because I'm still in the learning process. But from my knowledge is they seem to be one direction, so kernel to user space. And I know that they're implemented by a memory map and then a ring buffer, and so they're very, very fast. The next is a BPF helper call, which I'll talk about in a little bit. And so trace print K, it's really just a debug tool, but it is somehow getting information from BPF programs to user space. And from my knowledge, it's like a syslog sort of output at this path that you see before you. Okay, so I think that's enough of an information dump. Let's get into some coding. So as I mentioned, both of the programs do pretty much the exact same thing. And we're going to be counting different packet types. Woo. So here we are. We have user space and kernel space, and we have our process. So another thing I didn't mention is that all your interactions from user space with the BPF subsystem is done through one syscall. And there's a lot of functionality packed into that. There's so many different functions and that are multiplexed through this syscall. So this one, for example, will create a map. Obviously, this is a summary of what it's doing. There's other arguments to go into this. So when we create a map, we get a file descriptor and we have a map in kernel space. Next, what we're going to do is we have our program. For clarification's sake, the program isn't actually outside the process memory. It's just for drawing. It makes a little bit more sense this way. And so before we actually load the program, though, the program, assumably needs to access this map. And so the only reference we have to this map is through this file descriptor. So anytime we want to access it, we actually use the file descriptor and place the runtime value of that in our program. And then we call BPF program load, and then it goes through the verifier, as I mentioned before, and then we have it placed in or loaded into the kernel, and we have a file descriptor to that as well. Next, we need to trigger the program because it's event based, and so we're going to use a raw socket. Raw sockets aren't the same as they're not really the same in terms of like a TCP or UDP because that's layer 4. These are, I think, layer 3 technically, and they get attached to a network interface. For us today, we are attaching to localhost. And then, everyone's pretty familiar with sockets. You get a file descriptor to that as well. And we're still missing that. We still have to attach the program to the socket. And so we can do that through setting a socket option, just attach BPF. And if that's successful, there we go. We have this lovely little picture. So let's go check out some code. So here's our program. We've got some imports here. Important things to note. So first, we create a map. We make it of type array, which allows us kind of an index type of interface. And so the other things for creating a map that we care about are the size of the key and the size of the value. And then this is the number of elements that map is going to have. And so here, we're going to use an I32 to index and use size as a count value. And then after clean up, you just close the FD. And here's our program here. So what I've done is I've added a bunch of like factory functions to create different instructions, and instructions are just 64 bits. And I'm not going to go line by line here. But what I'm going to note is first we're grabbing a byte which aligns with what type the protocol is. And then we're going to reference our map, and we're going to look up the value. I'll talk about this line here actually in a second. And then we're going to have a pointer to that value, and we're going to do an atomic add of just 1, just to count the packet. And then we're going to exit. So right here, you can see call, and then we have an enumeration literal. So this is called a BPF helper. Now, BPF helpers have a horrible name because you automatically think like a utility helper function. But in fact, they're an enumerated syscall-like function that makes up an interface between the BPF program and the kernel. And so when you are reading the raw instructions, it's literally, this will be like call 5. That's all it does. And these are all predefined. These are the only thing that's well documented in BPF as well, which is nice to have. And so another thing I've left out until here, because it's kind of a small detail, is that when our program first starts, the register R0 is loaded with the address of the context struct. And the type of that struct, for us in our case, because we're attaching it to a socket, is a sock buffer. And that's why we're able to grab this byte. And here, the reason why that context is that type is that right when we load the program, we load it as a socket filter. And so the type of that context depends on the type of program we load it as. And this is one of also the lesser documented sides of BPF. There's a ton of cool sounding program types and map types, but they're actual, like the details about them, I think you just have to go through kernel source code right now. That's something I want to fix. Here we create our raw socket. I've just made a function for this. We don't have to worry about the details. We attach as we saw. And then here we're just forking ping, and it's going to ping localhost for a little bit for us. And then here we got a really ugly loop that's going through. It's reading from the map at different values that correspond to TCP, UDP, and ICMP, and then just printing them out for us. So if we want to run our program, we can do, also we need sudo for this right now because I don't have the capability set up. So we do sudo zig build run ASM, put in my password. And then here we're printing out, and here we go. We're getting ICMP packets as we would expect if ping is running. And then ping sent over however many packets I set it to. And here we're no longer grabbing any packets. So that's that. That's the main idea behind like just manually doing everything. Now, not everyone, like while the bytecode is portable, not everyone wants to write bytecode. And oh, here we go. And so there have been a couple tools for this. So for the last like 4 years, most people get started on BCC, which is it stands for BPF Compiler Collection, and it's a Python-based framework. And the kind of like the way it's kind of similar to everything we've done here, but what you do is you do all your user space stuff with Python, and then you can write your like C for your BPF programs, and you use like Python as like the preprocessor, and then it loads it for you, and it's kind of odd. It's kind of jarring for me because I'm used to low level stuff, and having to deal with like high level abstractions but low level like mindset it's kind of jarring. And so the next thing that's coming right now is something called libbpf. Libbpf is in the kernel source tree. It's a C library, and and so it's everything C, and it does a whole lot for you. The thing though, what libbpf does is that it kind of defines an ELF layout where you can lay out different variables in different sections, and then the libbpf will know how to load those values in, as well as there's kind of a defined kind of path style for section names for different programs, so that libbpf can attach your program to a specific, like one of the things you can do is like a trace point. So you can specify that this program attaches to a trace point that lines up with the start whenever you would begin calling the open syscall. So I'm working on getting this sort of functionality down, but I think it's time. Let's look at our program. That's the pure Zig implementation. So we go here, and then it's compiled main. This is how. Actually, I want to show you the actual BPF program first. Probe.zig, and here we go. So couple things to note. Here this isn't super important. Here I'm creating a counters map, and this is kept in the link section, or the section of maps. And then here, this type that that I'm saving here is right here. So we got the type of the map type, key size, value size, max entries, and flags, which I haven't actually piped in yet. So that's saved there. It's saved in the map section, and then when the loader reads the ELF, it knows to look for maps inside the map section, and can grab all the information it needs about them. Here, in order to do that weird single byte read from the socket buffer, I needed to use an LLVM intrinsic, and it works quite well. It looks, you can notice that it looks quite similar to our bytecode here. And the difference here is I'm actually skipping any outgoing packets, and so we're actually going to have a count that is half that of the last program. And then here you can see I've added some nice methods for looking up the index of whatever the protocol is, and then getting that value. And then it's actually really nice. We can just use built-in atomics to do atomic operations, and it works really nicely. Another thing that's important is, I haven't mentioned GPL. If you don't license your BPF programs as GPL, there are a few BPF helpers that you don't have access to, but it's very trial and error. If it doesn't, if you're using things that non-GPL programs aren't meant to use, then the kernel will let you know. And that's that. And then so let's take a look at what it looks like in our user space program. So we've got, so this is actually something where I think Zig just does a really good job. So we got an embed file. So with a lot of the examples I've seen, they'll have the ELF object file, and then they'll have their normal program. And then the program will, at runtime, load the ELF file, do all the parsing, and then it does whatever it's meant to do. However, I don't like that. Feels like a tutorial way of doing things. I really like the ability to save a file into the actual ELF of the user space program, and then we can even do things with comp time, which is making sure that this is the right file and it has the sections we expect of it. Oh, I think I forgot to mention that I have socket 1 as the program section, but that's not super important because we don't have automatic attaching. So here, pretty general start to the program. We initialize our object, and then what init will do is that it'll just create all the maps for us, and then we'll have load, and load will do the relocations of the map FD to whatever programs are referencing it in that program code, and then load the code into the kernel. So this would essentially look the same for every program, which is nice. And then here, same thing, raw socket. We can use a find method here to get our program, and then attach the program to the socket manually. And then here we can grab our map FD as well. And then this is all the same. And then if we want to do just show this off, we can do sudo zig build, I think run compiled. And then here we got packets, and you'll notice it's at half the rate because we're not even caring about half the packets anymore. So that's kind of that. Like, I wanted to kind of help convey some of like what those tools are doing today. It wasn't super obvious. libbpf is like 10,000 lines of C code. And most of it's just ELF parsing. It's a lot of noise to get exactly what's going on, and they don't really have like a public standard of what's going on. So let's see. Yeah, so for this library, obviously I want to finish adding all the interfaces for the kernel into standard, or it's the standard library. At type struct was released or like added to master like 2 weeks ago. So it's something that I think would even make it better. We wouldn't have to have those find functions for the object. We could just load the object or initialize the object, load it, and then be able to just reference the maps by name. It would just be really clean. And another thing I want to do is make it compatible with libbpf, because if we do that, other people will have the ability to write their BPF programs in Zig, which is way cleaner and way nicer than just C. And I think I don't know, people might have concerns over like how stable Zig is, or even like the minor security stuff that it does under the hood, or the actual code that's created. But with BPF, it's already a safe environment, so that they can safely make those programs. Another thing I didn't mention, this is kind of the way of how things go. So the issue with all of this is that if we're doing socket-oriented stuff, we're fine. We don't have to care too much about kernel versioning. However, similar to like, we know that within the user space or the syscalls on Linux, we've got Linus protecting us, so no one's going to make any backwards incompatible changes. However, when it comes to like the actual internals of the kernel, we have no such promises. And so if you're running these programs and you're compiling them, and they're expecting a certain field of a struct to be at a certain offset, then any kernel dev they could add in conditional compilation for that struct. They can add field. They can remove the field that you're referring to. And so we're like, from one kernel version to the next, we could be like the ABI doesn't line up anymore. So this thing called BTF has been created. Stands for BPF type format, and it's pretty much just a debug info for all the types that you're using. You'll have like using the the task struct in the kernel, and then you'll be accessing this field named this value at this offset. And then what the idea is that you'll be able to have all the type information from the kernel that you're currently running on, and you'll be able to match up, and the field may not be available anymore, or it may have moved. And if it's moved, you can the offsets can be fixed for that. So you can have, I think the term is compile once, run everywhere. This is kind of like getting this to work will really make, and then this to work and the embedding the BPF program ELF object will make Zig and BPF just meld together perfectly. The only thing, like, I still have some figuring out to do here. The downside, the only things is, like, in libbpf, there's a bunch of BTF handling functions, and I know that there's a bunch of BTF functions within that BPF syscall, so I don't know whose responsibility is what in that regard. The other thing is, like, BPF is moving fast. I think there's more and more talks about it at Linux conferences all the time. Some of the things is BPF Linux security module integration, I think, was added as of July. Sleep, like the ability for BPF programs to sleep, which is a huge feature. I think that it's either the PR was like just last week, or it was added to the mainline kernel last week. And the other thing is the verifier does continue to get smarter. We were able to that relaxation from no loops to bounded loops was because people were putting in tons more effort into making it smarter. And so in the future, what you'll have is you'll be able to have larger programs and not have to care about the nitty gritty details as much. So I think, yeah, that's me. And if you have any questions, please go ahead.
Thank you very much, Matt. Okay, so let's move to the Q&A. Just remember, if you want to ask a question to Matt, please remember to tag me in the chat message. And don't forget, I'm not only looking at Twitch, but also Discord and the Zig IRC channel on Freenode. Okay. While we give a little bit of time for questions to build up, Matt, I have the first question, I think. Interesting that the kernel verifies the license and wants the 3 magic letters there. Yeah. What do you lose access to if you are not using? Like, actually, wait. Let me rephrase the question. First of all, does it have to be GPL? Like, if I put MIT there, am I going to get any restriction? And after that, what restrictions am I going to get if I get any?
Yeah, I think the restrictions mostly have to do with I think XDP. I don't have a list of everything there.
Sure.
I generally, the way I approach it, I mean, if you're writing bytecode, you're dealing with the kernel. So by definition, it's a derived work. So I don't actually know how people are able to, like, that's an option given to you, and depending on the license, you are exempt from certain things. So I don't know from the kernel dev's perspective, like, how you could create a non-GPL BPF program. But yeah, from my knowledge, like, it might not be too much that you lose, actually, from what I've read, but that's still more research into that.
Okay, that's interesting. I mean, so there's a system. I find it funny also that you have to, since tracks can change layout, then you need to find a way of getting back a name mapping for the offsets, which it's kind of hilarious because it's just use JSON. I'm joking, don't. But
just a comment though, just to say, like, just because the actual BPF program might have whatever you write might have to be GPL, your user space program can be whatever you want.
Mm-hmm. Okay.
Just wanted to clarify that.
I see. Very curious that now you have to check the magic letters. Okay, so let's see which questions we have now. Is there something special in your build.zig file?
It's surprisingly simple. I'll show you guys right now.
And also, this is a good
Rick-
excuse for me to, boom, show the new transition for the Q&A.
Ooh, nice,
Let's
nice,
go ahead.
perfect. So like all I'm really doing is there's BPF, little endian and big endian, and that's about it. And freestanding. Oh, also you only release fast because there's no way you can have like any of the release safe code in there, just because it's freestanding. But this is about it. If I think there's a couple things I need to add to the standard library. I think there's a couple like function calls that aren't in there yet that I'm using right now. But yeah, like it was surprisingly easy. Like I was like, I don't know if I'm going to get the right output or the sections are going to be right, but the Zig compiler outputs the right code. It outputs the BTF information, all the relative stuff as well. I hadn't like props to the compiler devs because like I had no issues in that regard.
So
Yeah.
that's a noob question, but do I get this right? So we do have a BPF backend then.
Yeah, it's from LLVM.
Oh, right, we're inheriting it from
Yeah.
LLVM.
Yeah,
Makes sense.
for a while, it was kind of odd where for the Linux kernel you'd use GCC for compiling it, but then for all the BPF stuff, because GCC didn't have BPF until I think recently, so everyone's had to use LLVM for dealing with that. And there's a couple hacky things that you need to do to like have that work nicely with the includes. Darnamator was telling me about it, but I don't remember all the details.
Okay, let's move to the next question.
Sure.
Let me see. Okay, this one is from Andrew. Can you give an overview of the capabilities of BPF? What kinds of crazy things can we do with this?
So the number of helper function calls, I think there's about 130. This can be, I think some of the bigger ones I remember is you can get access to the task struct that's related to the PID that your event is related to. All the XDP stuff is very cool. Then there's all the tracing. You can get for the tracing, you can use K probes, U probes, which are I'm again not I understand the basics, but I haven't done extensive work with them. But they're like dynamic probes that you could do. You could do a bunch of you could get the full stack or the stack trace from the kernel for different trace or points within a user space program. You can hook to the enter and exit for different syscalls, and I think that's all I know of right now that I can think of. And then then there's just like a ton of networking. Oh, and there's like one weird case that was added a while ago, and you could interface with the IR Blaster Linux subsystem, like for the little IR like controllers. I don't know what that's all about, but it's in there.
I think there's also another interesting use case that I stumbled upon recently, which is not strictly kernel related, but it is related to the BPF bytecode. When I was investigating, just so that I don't look like a complete ass while Matt talks about it. And apparently there are at least one blockchain that is using the BPF bytecode as their language for implementing smart contracts or whatever they call, the scripting capabilities that some blockchains have, which is interesting. They are using BPF because they kind of have some of the same constraints that you kind of have in the kernel. You don't want it can't crash, it shouldn't crash. You want to limit the amount of competition that the script uses, etc., etc. So that's also, I think, another interesting use case.
Yeah, I think I'll also like take from watching the talks. I think I meant to plug in some of the talkers that present on this topic a lot, but from like the people working on BPF, they're kind of seeing this as like the next move for the Linux kernel, like having BPF programs kind of replace the kernel module overall. I think actually maybe not quite, but creating like another way of safely doing that. And so I think they even like I've heard mention of they want to be able to do like device drivers and BPF and just have it like all over have it be able to interface like the entire kernel. Yeah, like I mentioned, like the BPF security module is just added, so that's like a huge new swath of abilities that BPF can do, and yeah, just wanted to make that note.
Mm-hmm. Okay, we have another question. Matt, would it be possible to implement a custom protocol besides the IP layer with BPF?
I think that's totally possible. Especially like if you wanted to make alterations to like TCP, you could totally do that. Actually now I remember some of the BPF helpers. You can change the actual body or the data in the message, and then you can a nice little BPF helper to help you recalculate the checksum. So you can do some really funky stuff in that regard, and you can like in terms of the networking. It's very, you can have a lot of like read-write access. The tracing is very read-only, but there's possibility to do stuff like that for sure. That's very very much under like the XDP umbrella.
Okay, awesome. Felix is saying that makes some project of mine easier. Okay. Okay, then I think that's all for the questions. Thank you very much, Matt. Is there anything else you want to say before we leave?
Thanks for having me on. I really enjoyed myself, and hopefully I'll have more to talk about in the future.
Sure, I would totally be happy to have you come again in the future. Thank you very much.
Thanks.
Bye.
Bye.
Okay, so now 10-minute break, but don't go away because after the break we have another interesting talk. You saw it in the beginning, coding by voice in Zig. So see you soon. Okay, we are back. So, there's a very interesting quote that I read in a math book a few years ago. As usual, I don't remember the quote. I do remember the quote, but I don't remember the author. But anyway, the quote goes, "Interesting things are found where opposing forces meet. And in many ways, computer science is at the meeting point of many opposing forces. Theory, so let's say math versus engineering, efficiency versus dynamism, good, respectful user experience versus venture capital. I could probably go on forever. Our next speaker, Rickard Andersson, went from programming in functional programming languages to wanting to get closer to the real machine, which eventually led him to Zig. And at the same time, because of a personal need, he learned how to code by voice, finding, in a way, another dimension where the abstract art of expressing sound ideas meets the harsh mechanical truth of the physical world. The title is Coding by Voice in Zig, and Rickard, the stream is yours.
Thank you, Loris. That was very poetic. This is going to be a very practical sort of talk. The main part of it is dedicated to a demonstration of writing Zig code by voice, but let's jump into this and see what we can figure out about coding by voice. So what does it mean? This is what we're going to go through. What does it mean to code by voice? Because I think a lot of people are probably, they don't know what it means. And if you haven't seen anyone do it, it can be hard to sort of, it can be hard to visualize this, right, in your mind, what actually happens when you code by voice. We're also going to go through shortly why you might want to do it and who might want to do it, and then how, which is the practical side of what does it actually mean in practice to write code by voice, like what are the practical considerations. And also a bit about how well does Zig do in this regard. So let's get through it. So from an ideal perspective, coding by voice is essentially speaking to your computer and your computer understanding you. Reality does not really match this. The reality is rather that you speak, for the most part, people usually speak something like Vim to their editors. Also, they speak handcrafted grammars, handcrafted for certain languages, certain programs, and so on. And what happens when you do that is usually you bump into every issue that the English language, because people primarily use this, of course, every issue in the English language will essentially bite you. There are a lot of homophones, things that sound alike, and so on in the English language, and you end up essentially bumping into all of these. Why might we want to code by voice? Well, a lot of people obviously have disabilities that essentially make using a keyboard very hard. They might not even be able to use a mouse and so on. For these people, obviously, they will have started out essentially coding by voice. And this is entirely possible. We might also have typed too much, and at some point we will cause damage to our hands. We might also have typed too much and played too much StarCraft and Quake and every other game out there, and we feel like our hands are going to fall off at some point, and maybe we wish they actually would, so they would stop hurting, right? This was the position I was in at some point. It probably wasn't as bad as I made it sound on this slide, but my hands were essentially in a state where typing, when I got up in the morning, typing for work, they hurt a lot. And the nerves in my hands were essentially hurting just from the constant work of typing all the time. And this, of course, this can depend on a lot of things. You can have bad form. I think I have bad form. I learned it on my own at some point. And yeah, when you're self-taught or whatever, when it comes to typing, it's probably not the best situation. I also worked a lot at some point and typed a lot as a result, wrote a lot of code, and this ended up hurting my hands a lot, combined with the StarCraft and all the things. And so I had to find a solution, and that solution obviously was coding by voice. And how do we do this then? Well, most of the solutions actually are based on one single program, or rather one single base program for dictation called Dragon. The version I use is Dragon Professional Individual 15. This was called Dragon Naturally Speaking before, and that's what the product is still based on. This is an old product. They've Nuance, the company that makes this, they've been making this product for a long time. Below this, we use, or rather, on top of this, I guess, we use a program called Natlink. This actually interfaces with Dragon, and so Natlink, then we use a library called Dragonfly on top of, in order to script Natlink. And so this is the part where sort of the customization on your part, the user, comes in. You write these grammars in Dragonfly. And the hierarchy of these is essentially a low-level grammar, where we essentially specify characters, symbols and characters. And this allows us to speak Vim, essentially. And then we have a higher level layer where we can specify things like format whatever I'm going to say in a certain way. And we'll go through all of these. On top of that, then, you also have higher level language layers, or these can be application layers, where you can do advanced branching based on essentially you say a thing and it might branch into a decision tree and so on. And so the lowest level layer essentially looks like this. We want to say the letter A. So we say air. B is bat, and so on, right? And you can see here that we use ship instead of shift, and so on. And so we say, when we say ship air, that's actually uppercase A. These symbols here also have names, of course. We can't very well say right curly brace every time. So we say things like lace, race, lack, rack, lice, rice. These are all personal choices where the user obviously chooses which things to say here, right? You might customize these over time because you find that rice actually sounds to the dictation as race sometimes, and so on. The important thing here is that you have a way to actually say these low-level operations, because this is essentially how, for the most part, with my scheme at least, you'll move around in your editor and you'll sort of do the normal code browsing that you would do in Vim, for example. And so on. Here we can see that we have sequences, of course. You can sequence these commands, so it's not that you have to say them just one at a time, waiting for your software. You can say drum sit dub, for example, for di quote, double quote, and so on. So this is essentially, we can see here in the bottom right that we want to do fairly simple things. Like if we're familiar with Vim, for example, we have this $%s debug info and so on here, where we want to replace the word debug with info everywhere, everywhere it shows up in a file, right? And we have this very long sequence. So this obviously begs a much neater solution where we can say less and still get the right result, right? So we get to a higher level layer where we specify formatting, we can say words and have them output properly, right? So immediately in this, we can see that we have the command say, and then we say a phrase. This will simply output that phrase. So say debug will just output debug, right? So we don't have to spell debug now. If we say snake, this is it. We get this score, is score, it, and so on. So these are obviously very useful in programming languages because we have different casing for different things and so on. In Zig, obviously, this is not a consideration that is technical. It's more cultural. It's a style issue to a large extent. But in many languages, this makes a big difference, right? And these are essentially, in your grammar, you just specify these as functions that modify strings. So you're completely fine to make your own. For example, this ADA casing that I've made has not been there the whole time, and I don't personally need it, but I added it just to do it. So even if you have an exotic casing scheme, it's not going to be an issue as long as you can write a function to do it. So we can see here in the sequences that the debug, replacing debug with info everywhere has become considerably shorter, right? We have :person / say debug / say info and so on instead of spelling these out. And essentially, you will just use these in your normal Vim fashion, essentially. You will just say camel when you need a camel-cased identifier and so on. And these, again, are, you can sequence them with normal letters and so on to get this sequence of commands. Where it really gets interesting, perhaps for the higher level and the day-to-day sort of writing new code style, is higher level layers where we have advanced grammars. And I don't have examples of these because I will show them, show the SIG ones. But what they do is you can effectively speak your programming language. And if that sounds odd, I hope that the demonstration will show what that means. And these are very useful, of course, to get consistent structure. Obviously, when we type things, at any point in time, we essentially have a choice to misuse or mistype a feature and so on. And this can be varying levels of dangerous or bad or just small nuisances, right? But if we essentially say for loop, just as a command, right? Very simple command, this can output a for loop for us, sort of like a snippet, right? We can then extend that into a more advanced grammar where we say for loop over something, which will automatically fill in something to iterate over and so on. And these sort of ensure that you're using the features, for example, a for loop or typecasts and so on, correctly. And there are some downsides, of course, with higher level grammars. They can be, you can sink a lot of time in these. And you have to effectively use voice coding with the language for some time to recognize needs for certain parts of the grammar. You very likely will not, see, for example, that supporting a certain keyword is important until you have a program that requires you to do that constantly. And if you use the lower level grammars, the Vim bindings and the just saying the casings and so on, you might actually type this wrongly all the time. And so you might recognize at some point that using this feature of the language actually requires a more advanced grammar, where you, for example, say cast something into U64 instead, because you constantly forget that it's int cast and not something else. And like I said, this can be a massive time sink. If maintaining an Emacs config or a Vim RC is a time sink, I think this one dwarfs these, because it's obviously a thing you can work constantly on, and you can always make yourself a little bit more effective, right? And this kind of changes over time as well. Your needs change with the project. When you write a lot of new code of a certain character, you kind of bump into a lot of features of a language. And when you only maintain code, suddenly the lower level bindings become a lot more important, because just browsing your code kind of just requires these small movements, the Vim movements and so on. So you might not need these advanced grammars anymore, and you've sunk a lot of time into them and so on. So on to the demo. And full disclosure, I'm a little bit nervous, but I hope we'll get through this. So here goes. Wake up. Focus demo. Wake up. On. Public function main. Escape. Find score sun. Together any error. Bang. Say void. Escape. Find race. Sit slap. Constant argument. Try method. Say process. Escape. Find score sun. Air red gust. Control space. Go one down. Tabby. Escape. Find rise. Drum purse. Air. Library dynamic memory. Prick. Snake page allocator. Escape. On. Constant program name. Indexing 0 into argument. Escape. On. Slap. If argument.len is less. Escape. Ship find air cap each. Say argument prick look each near. Escape. Find rise sit 3. Escape. Find race sit slap. Escape. Find kick. 4 kick. Ship on. Constant standard out. Sit on prick say get. Control space. Go 2 down tabby. Prick say rider. Lice escape. 5 gym. Ship on. Try method escape cap cap. Try method print on standard out. Semi escape. Harp sit. Harp sit. Dub proper usage colon space lace race space langle say word wrangle space. Langle say files prick 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 wrangle backslash near. Dub spammer prick lace. Snake program name escape. Gym on. Tabby. Method exit on process. Semi escape. Harp sit 1 escape. Gym on slap. Constant word. Indexing 1 into arguments. Escape. On. Constant files. Indexing 2 onwards into arguments. On. Backspace escape. On. Constant directory. Find sun. Brick. Cap whale drum. Lice. Escape. On. Variable file buffer is undefined. Escape. Ship find score sun. Index 1 million. Urge 8. Escape. On. Slap. For loop over files binding life. Escape. Ship find look. Cap each. Say file. Escape. Bat cap each. Say file. Escape. Find race. Hit slap. Constant file descriptor. Try method. Escape. Ship find trap. Cap trap semi. Try method open file on directory. Escape. Sit. Say file spammer. Prick lace. Prick say read equals. Say true. Escape. On. Constant file reader. Method reader on file descriptor. Escape. Ship on. To do comment, close this file descriptor. Escape. Ship finds it. Cap dollar. Say descriptor. Escape. On. Defer. Defer. Method close on file descriptor. Semi. Escape. Kick drum drum. Drum drum. Gym on. Escape. Urge. Urge. Gym on. Slap. binding line while try method on file reader, escape, ship find cap each, say file, score, control backspace, say file, score, say reader, escape, find writes, sit, control space, camel read until, backspace, proper until, go to down tabby, ampersand snake file buffer, escape, find drum, cap trap rise, sing \near, escape, find race, sit slap, unpack into position, method index of, made each made, escape, find rise, sit, urge 8, spammer, say line, spammer, say word, escape, find pig, sit score, escape, ship on, comment, we don't care where we find it, escape, Jim, find race, sit slap, try method print on standard out, escape, ship find drum, sit, escape, bat cap each, snake standard out, escape, find rise, sit, dub, lace race, \near, dub, spammer, pricks lace, say line, escape, ship air semi, control sun, escape, space each pit, escape, space each pig, find lack, sit, sun, escape, control sun, escape, control trap, zig build, slap, zig cache bin, tabby, say sum, tabby, space, say word, space, source, backslash, source, backslash, say main, prick, say zig, slap, go one up, escape, ship find whale, cap each, find near, escape, ship airspace, say build, prick, say zig, slap, focus presentation, press F5, go to sleep. And so that's it for the demo. It went at varying levels, of course. So there are some pros and cons of Zig when it comes to coding by voice. Honestly, a lot of the cons have sort of been solved in time. When I started doing voice coding with Zig, it wasn't so easy because there are a lot of places that are hard to reach. Well, harder to reach. For example, if we look at the cons here, there are some C-isms and so on, like PTR and so on. That's pig trap red and so on. And I found that 3-letter words aren't so terrible when it comes to these. You can say 3-letter words and so on, but it becomes an issue when people call things like MSG buff and so on. These are not words, right? And there are way too many letters to actually say like this. And you can make grammars for these, but it's very tedious. Having to say pointer and having it write PTR it's not useful when it clashes with other rules and so on, right? Luckily, ZLS actually makes these things much easier. So that's essentially been solved, where CLS allows you to, for example, these words like args alloc and so on. These were fairly hard to reach probably before ZLS. This particular one, I don't know. I don't have any memory of struggling with, but ZLS makes it extremely easy to find this in a list of functions, right? And before that, this wasn't really a thing, right? Of course, Vim, I guess we had like Zig tags or something for Vim, but it wasn't really something that I used and so on. So it was fairly hard, right? I didn't really do much voice coding with Zig at the time. But yeah, CLS solves that. The fact that we have a small set of constructs, the language doesn't have all that many things inside of it, right? And a lot of the constructs, they actually follow the same pattern in some way, right? I have a grammar for type definitions, and most of them are actually fairly similar. I reuse the same functions inside of the code in order to output these, and we can look at these just a very short while to sort of show how the code looks and how the grammar looks, and how you can sort of see how Zig makes this fairly easy. On top of that, you actually have a thing that can seem tedious to a lot of people, I suppose, when you have a lot of signposts in your code for a language, right? The braces and things like that, right? And you use special signs for certain things, right? The reason I'm calling them signposts is because you can sort of follow them. You can jump around to them, right? And I didn't personally feel this as much when I was just using Vim typing, right? But you feel it more when you start code golfing your traversals, right? Because you're speaking these now. So jumping to a thing becomes a lot easier when you have a comma in places instead of just spaces between arguments and so on, right? Many languages, or some languages, prefer to not have any of these signposts because it's cleaner when you type, I suppose. But it turns out it's not a lot cleaner when you actually speak these things and when you have to jump around fairly effectively and so on. There are some obvious issues though. I made a grammar bit for calling conventions, and it uses precious few real words, of course, because one of them is C and one of them is actually naked, and that's a real word, so that's fine. But you end up having to make a grammar because std call is not actually something that you can just say even with your formatting constructs and so on. And conv is not actually a word either, so you kind of end up, you have to make grammars for things. We still have a lot of these things. The reality though is that these are rarely used to some extent, right? You don't end up bumping into them so much, right? But yeah, let's just have a quick look at sort of the grammar code to sort of illustrate, like, here's what it kind of looks like, and then I will finish up the talk. Wake up, focus, dragonfly. Zip trap, go to sleep. So here, obviously we can see that there's a lot of duplication here. Some of these are just, this is the easiest way to do it, but we're reusing a lot of things. And the thing that I was talking about here, we have this struct union enumeration. This actually reuses the same code. It's just a matter of changing the definition type here. This is literally just sort of passing different strings into this construct, right? This is because all of them are just const something equals something, right? And this is extremely easy, and probably to some extent, I suppose, I will eventually be also passing in functions here if we switch to this. I don't know if that's actually on the docket anymore, but it was at some point. So it might be that function types are also in this sort of area. But yeah, so we have different convenience grammars and so on. This is not a big grammar by any means. It doesn't support all of Zig, obviously, but there's a lot of flexibility here. Almost all of these constructs have a version where you don't say a name or you say a name and so on. And this is very easy to support. We essentially end up writing just normal Python code. Some of it is actually terrible, but that's also something that you end up with. If you think your Emacs code is terrible, then yes, your Python code for Dragonfly is going to be also terrible. But yeah, so let's, I have a few talks that I think people should watch. If I could go to the end. So I was inspired, and I think a lot of people are. I think almost everyone in their talk about this actually says that Tavis Rudd at PyCon 2013 was where they saw coding by voice the first time. I personally think when I have gained more perspective on it, that it wasn't so useful to actually figure out what coding by voice actually is. Because it seems like too much magic to some extent. David Williams King has a talk in 2016 at the 11th Hope, where he actually goes through what does it mean to build a speech recognition engine, and he also goes through why he did that, and he also has tried to build an open source alternative, because Dragon is proprietary. It's a paid thing. It costs a lot of money. And then I'm not going to attempt to say this name. I'm sorry. At PyGotham, this guy did a talk on coding by voice with Dragonfly, which is also good. And Emily Shea did a talk at Strange Loop 2019 doing the same. And I think she has a good demo of what people actually think coding by voice means at the beginning, and it's very comical. But yeah, that's it. If people want to see more demo stuff, I'm sort of hoping to show some stuff if I can. But yeah, that's it.
Thank you very much. By the way, okay, let's switch to the Q&A view. By the way, your demo was amazing. I think everybody in Twitch chat was blown away. And as you said, doing it in front of people is very different than coding by yourself in your home. But I think it was also interesting for everybody to see how you can also fix problems, like react to misunderstandings with the voice software, by the way. And yeah, everybody was very much surprised. So thank you very much. The demo was amazing.
It's extremely, my heart was going places, I can tell you, during this. There were way more errors, but the truth is also there will be errors. Like you said, the voice recognition engine actually, it tries to make sense out of what you say, and a lot of code doesn't make sense as sentences, right? So yeah, you end up doing some Vim modifications and so on at some point.
Mm-hmm.
But yeah, the important part is that you have the Vim layer to make these modifications, right? Because that's essentially these small incisions into code is where the Vim layer actually shines, right? That's why you need it. Otherwise, we could just speak perfect code all the time and make no changes. But this is not reality, right?
Mm-hmm. Right, makes a lot of sense. So there was a small question / discussion while you were presenting about escaping keywords. So at one point, I believe you said say, then a sequence of words, and then you ended with escape, but the escape or slap, but the slap was taken as a new line, not as the literal word slap. So I am assuming it's a matter of pauses. Is that it?
Well, it's essentially a matter of precedence, and I suppose also pauses. But yeah, if you, I honestly haven't noticed if I pause before I say escape. Maybe I do, maybe I don't. The truth is, I think escape has precedence, right? So that key will essentially always end a thing. But yes, the software has a certain time limit for reacting to commands. So if you do wait it out, you're essentially going to start executing what you said. So you batch all these things together and then it executes it, right? So yes, you can wait, and effectively at that point you will certainly just execute a new command. You will not be continuing the dictation that you were doing, right? Because these formatting commands, yes, they are essentially a formatting command and then a dictation. So for example, if we say proper, this is a test, we get this is a test altogether with title case, right? I could show this, of course. I don't know if this perhaps wasn't necessarily something that people were confused about, but just to be clear, wake up, disable Zig, enable Python, sit, comment proper hello, this is a test. Escape, ship fine pig, bat cap dollar, proper this is a test. Escape, ship airspace, camel this is a test. Space, barbecue this is a test. Space, say this is a test. Space, uppercase this is a test. Escape, air, space, snake this is a test. Escape, go to sleep. So yeah, this is what the formatting commands essentially are all about. And when you can slot these in, you're fine to just do so, right? But yeah, if it's about pauses, I haven't noticed. It's just maybe natural pauses. I don't really know. But escape is effectively will always take precedence. You will exit insert mode. I don't know if people noticed, but I do actually pause after escape, and this is not because of the grammar or the Dragonfly plugin or anything. This is actually because of VS Code. I don't know if I can illustrate this. Perhaps I can. I'm going to try, and we'll see how this sort of manifests. And this is an issue, but it's an issue with VS Code. Wake up, ship airspace, sit, escape, sit, go to sleep. So I said sit, escape, sit, which means I, escape, I, which should have just gone into insert mode again. But what you get in VS Code is actually you get an extra I at the end there. And then you exit insert mode. So effectively you get whatever you said before the escape, rather after the escape, you get before you exit insert mode. And this is because VS Code is slow. That's actually the output for some of these constructs is actually slower to exit and so on because of VS Code. In NeoVim or Vim, these would be faster, and that's sad, but it's not a showstopper. And it's because of this issue. When you exit insert mode, you have to wait a little bit before you do new things. And yeah, I don't know if it's Electron or whatever it is, but that's sort of how it is.
I see. So out of curiosity, how would you write escape in a comment then?
Oh, well, actually, okay, hang on. Wake up, on, hashtag space, say escape, space, snake, this is escape, go to sleep. I think this illustrates the thing, right?
Yes, thank you very much.
Yeah, so you end up, if you actually have already said things, escape will always exit, right? Which means that, yes, this is a special case. You just have to deal with that. You end up running into a lot of special cases where you're like, okay, how often do I actually need to say escape?
Yeah, sure.
I will take the fact that I have to say escape, right? But this is tedious, yes. There's a lot of tedium when it comes to a lot of these things.
Yeah, and this all boils down to the way you set up your grammars, right? You could have a different setup.
Yeah. I've seen people actually use, well, there's a program called Voice Attack. I don't know if people have heard about it. Voice Attack essentially lets you speak commands. They're fairly simplistic in comparison, but I saw one person, don't remember his name, very sorry to that guy, but he had a video on coding with Voice Attack where he actually went into dictation mode, and then he said essentially exit dictation mode. And at that point, you're not using escape to exit, right? You're just saying, I'm done dictating, program, output, whatever I said. And for that kind of mode, yes, you can just say whatever you want inside of there, and then you have this magic phrase that you will never ever say in normal usage that ends dictation mode.
Your safe word. Makes sense.
Yeah.
Okay, thank you very much. So this, I guess, answers basically one question. Another question, so you showed Python. What other languages are you able to program in using the voice system?
Well, okay, so I have this one that I've named Curry. And this is, it's named Curry because it's not only for Haskell, it's also for pure script. I work with Haskell, and I do it by voice, at least lately. Haskell is not all that great for voice coding, it turns out. When I mentioned languages that refuse to use commas between words and so on, Haskell is one of them. Haskell has a very Haskell doesn't have auto formatters either, so that's an issue. But yeah, this grammar is for Haskell. It's significantly smaller, not because Haskell requires less, but because it's not as thought out as the Zig one. And I use this for Haskell, and I've used it for PureScript as well. So this one is for both of those. You can see up here, I also have JavaScript, but it's actually for TypeScript because, well, you know. I didn't actually show my terminal grammar. This is not obviously a programming language, but it does have these, for example, wake up, focus demo, control trap, Zig build, slap, Zig build cache, control cap, Zig cache bin, control cap, Zig cache bin, tabby, say some tabby, space, say word, space. Actually, I did show this. Did I not? Well, actually, I did show this.
Yeah, you showed the
Now
program
I'm
invocation.
just confused. Oh yeah, so I have this terminal grammar that sort of allows this, right? Focus dragonfly. Go to sleep. Also, well, I started out doing this actually in Elixir. So yes, that one as well. I haven't looked at that grammar though for a long time. But it shares a lot with the Python grammar, I suppose. But I would say the one that I've actually worked the most on, and I think this is common for a lot of people who use Dragonfly, is that you are forced to write a lot of Python. So you end up doing a lot in your Python grammar. And yeah, Python is actually fairly easy when it comes to this. But yeah, probably Python is the one that's most developed, except the Zig one actually covers more corners, let's say. I have some bits of the Zig grammar that deal with very interesting things. Let's see if I can find this here. So I have a typecast grammar that figures out what casting you should use, depending on what you actually say. I don't know if I can demo this. Wake up, disable Python, enable Zig. Let's see. Sit, cast something into U64. Slap, cast something. Escape, on. Cast something into float 64. Escape, on. Cast something into short. Escape, on. Cast something into character. Escape, go to sleep, and so on. So I think I cover more of Zig as a language because you sort of need to. And I've probably done more interesting things when it comes to Zig than any other language so far. And these would be among those things.
That's very interesting. Okay, thank you all also for showing that snippet. Yeah, that makes a lot of sense. Let's see, other questions. Let me see. I know we have a couple more at least. So when you're coding, how do you make sure your voice keeps clear enough?
I don't. I mean, that's the simple answer. Is first of all, I didn't mention this in the talk. I should have clearly. You get voice strain if you do this. Like if you do this for work, your voice is going to take a beating. It's not just your hands that take a beating. Your voice definitely will be tired at times. I've also been sick lately, so that certainly doesn't make it better. right? So yeah, your voice first of all will deteriorate over a day. You will notice it because you speak all the time, right? This is not normal. You shouldn't talk that much. So that's one thing, and also I don't enunciate clearly. So I at least end up in situations where Dragon constantly mishears me, and it just these are just things that I have to deal with, right? And I think at least as a non-native speaker, you definitely will have odd pronunciations of stuff, right? And this is inevitable. I don't think really. Well, to be fair, I don't think native speakers also would have just pronunciation that Dragon figures out completely either. You end up in situations where, for example, you can't say git and have it assume that you're saying git the command, right? I have a terminal command especially for this because it thinks you're saying, like people from the South in the US say, go on git. So, it thinks you're saying get. You're actually saying git fairly clearly. Like it's not an issue with you. It's an issue with just how it thinks you're speaking. And you can actually set where you're from in Dragon. So it's not that the product doesn't take this into account, but I've set it to neutral English because I don't have an English, like an American accent, right? But it just assumes he couldn't be saying git. He has to be saying get, right? Because that's what normal. But yeah.
I see. We have another question from Andrew. Does all this voice practice help you to sing?
Well, I wouldn't know because I don't sing. I haven't tried. So no, I wouldn't assume so. Because actually, I would think that if someone spends their day coding by voice, they're not going to be doing gigs on the side. Is what I'm actually going to say. It just will strain your voice, I think. I think you can make this better somehow. I don't really do enough to sort of combat this. I guess I will in the future. But in truth, the real plan is to do maybe 50% voice, 50% keyboard in the future. Lately, I've been doing 100% keyboard or 100% voice the last month, for example, right? I don't think that's necessarily what you want to do, though, like in the long run. You can type. You just don't type when your hands hurt, and also don't type all the time. Is basically the plan.
Mm-hmm. Okay. Let me see if there's any other questions. I think I have a last one. Actually, no, there's one from Benjamin. By the way, you gave yourself away. The question is, can you do more accents? I think the one worked really well.
Actually, let's try one. I'm gonna try if Dragon figures out what I'm saying during this one, because I think this one is interesting. Wake up. Ship on. Say coffee. Go to sleep. I suppose it does know that you're saying coffee, but yeah, I don't know. No, I can't really do a lot of accents. No. But yeah, this one, the get one, I've thought a lot about, right? Why would it think that I'm saying get? Well, the only thing I can reconcile this with is obviously it thinks I'm from the South and I'm shooing someone off my property, I suppose. I don't know why it would think so, but yeah.
Okay, so final question from me. You mentioned StarCraft. What's your favorite race? How often did you cheese people in ladder?
Okay, so I was one of those insufferable Zerg players,
of course,
that refused to cheese for a long time.
Oof.
A long time, because
So,
I was like, that's not honorable.
So you got cheesed by Protoss then?
Yes, exactly. Yeah.
Right.
Just it was 4 gates back in the day, and then
Right.
So, but then I started only cheesing for a while, because I saw No Regret. If someone knows this player, he is famous for doing early pools, literally every game, and I thought that was fantastic. So I was like, well, you can have fun also, right?
Yeah.
But yes, mostly a macro player though, to be clear. Not a very good one, but you try honorably.
Yeah. Awesome. I think we have another question that came in the meantime. Can non-English languages be used?
I wouldn't know. I think dictation works, right, for German, Russian, Spanish, English, as far as I know. Can you use them for actual programming? I wouldn't know. I don't know any of those languages. I know Swedish, English, and Bulgarian. So the only one that's open to me is English. And if I'm being completely honest, I wouldn't assume that any of the non-English ones are all that useful outside of like business emails and so on.
Yeah, I have to say, like watching your presentation made me realize that I'm kind of disappointed that there's this group of people working with artificial intelligence, doing all kind of crazy things, and they are focusing on plain data matches and other stuff. While this, I think it would be a perfect use case for a more, let's say, flexible system that tries to mold itself after your tone, your pronunciation, your own quirks, and I think this could be probably a perfect example of a good use case for a machine learning type of approach.
Well, yeah, I think so too. The problem is, of course, Google actually has a service that does voice recognition, right? And you can actually tap into this, get results back, and so on. Someone has actually made this. They've interfaced with this with Dragonfly. They've made a layer to talk to Google's stuff. I wouldn't use it if I'm being honest, but that's because I don't like Google. So if it's sent to another server, I probably wouldn't really use it. Do I trust the new ones, the company that makes Dragon? Well, not completely, I suppose. But I do think that they're kind of, harkening back to what you're saying, they're kind of the only game in town when it comes to actually delivering a solution. So yeah, I would want to see more energy being spent here, perhaps, right? The issue is, of course, like what would that take in terms of shape, right? I want something to run locally. And it should be said, new ones actually, they're not, as far as I can tell, they're not the most robust necessarily, but they do actually do learning on your patterns and so on. So there is some level of adaptation that goes into, well, when you use Dragon over time, it will figure out kind of what you're saying. As an example of this, I don't understand exactly what has happened over time, but I don't think it ever recognized grep before. But now when I say grep, it realizes that I mean grep. And I think that wasn't the case before. So I do think that it's learned something from, I don't really know what. Like when I've chosen to spell something and it sort of has recognized, okay, that was actually grep. That's what he meant. But then again, I mean, this might be me just seeing something where there's nothing. I don't know. But there is some level of adaptation here. I would like more energy being spent on it, though, especially the open source alternatives. I've tried one called Kaldi, and it's unfortunately not. It's not useful. Like when I started doing this, I actually had to get going, right? Because I was still working, and at the time I was working a lot of hours per month. So I needed to have something that actually worked, and Dragon definitely actually works.
Okay. Thank you very much. Before we leave, I also want to mention that Rickard has a YouTube channel where he put a few, how many videos of yourself typing? Voice coding.
Well, yeah, typing sort of. Yeah, I don't know what I'm up at. I'm like, it's 8 or something. Effectively, it's actually sort of, it's chronicled my journey from only using essentially the Vim stuff and formatting into using this advanced grammar for Zig programs. What you saw is the latest iteration of writing Zig code with my stuff. I've also made that repository public, the actual bindings, the actual grammar and so on. I guess I'm Gons on IRC, and something very similar on Discord. So if anyone wants more information about anything really, I'm also available there. I don't know if I've given the channel to you, maybe?
You did, and I just posted it in Twitch chat.
Ah, right. Okay. Yeah. That channel has a few videos. It has some helpful tips about sort of how to do things. Also some neat browser plugins that become very useful when you only speak commands, right? And so on. But yeah.
Okay, thank you very much. I think the part that everybody liked the most. Everybody was going crazy during your demo, but the thing that really everybody enjoyed, which I hope you don't mind. I think I'm gonna steal, is how you bound slap to new line. Ending everything with a slap sounds perfect.
Yeah, there's also prick. I think people will probably like that one. But yeah, it actually turns out that, I mean, prick is obviously a neat word to say also, but it's also dot in Swedish. So it's sort of matched. It's nice to say prick. And also you're saying dot, but you're saying it in Swedish, but with sort of an American lean or whatever.
Nice. Great. So thank you very much. Any final words before we end the show?
Not really. Take care of your hands. Stop typing if it hurts, or even before it hurts. It's gonna happen to you. It's gonna happen to everyone basically at some point. So yeah.
Okay. Thank you very much. And
thank you.
We can now move to the end of the show. So, whoa, that was something. I forgot how intense it was. Might not look like it from home, but it is kind of intense. So thank you very much to both speakers. I think we had a great start of the new season. Before we end, just a couple of things. So first of all, please, if you have anything even mildly interesting that about Zig or related topics that you want to share with the community, please apply to speak. We are still looking for more speakers. I don't have all the sessions from now until the winter break. So if you do apply, know that you will be able to speak relatively soon. You will still have enough time to prepare your talk, but you won't have to wait ages either, which I think it's nice. Second thing, the next episode is set for Sunday the 30th, so next week, but on Sunday. Also, there was a interview with Andrew that was done I think a few days ago. And I'm going to share it on the chat. So if you are interested, take a look. It's a nice interview where Andrew talks about Zig in general and the development and stuff. It was pretty nice. Finally, please take a look at the Zig Showtime YouTube channel. I'm gonna add more content there that it's not just the live stream on Twitch. So you won't see that content unless you find it on YouTube. So I would say check it out and please slap the subscribe button. Anyway, that's it, I guess, and can roll with the outro.
This is how we